Hi, my name is Duncan Kim, and I'm a junior majoring in artificial intelligence. And I decided to do a research survey on efficient vision transformers. So, what is transformers? A big challenge in natural language processing is that to effectively encode a sentence, we want to try to model the relationship between words in a sentence. A solution that was proposed for this problem that gathered a lot of attention was transformers. Transformers utilize multi-head self-attention, and it is the model behind recent advancements in large language models like ChatGPT, and it is particularly useful and effective with sequential data, like natural languages. So what is vision transformers? Vision transformers is a variant of transformers optimized for modeled for the computer vision domain. And the key idea behind vision transformers is that we are trying to treat an image as a sentence of patches or words if we translate to the NLP domain. And vision transformers have gathered a lot of attention due to its very high accuracy. And a lot of applications of vision transformers have been proposed ever since it was first released. So it has been used for object detection or video understanding or image classification. One problem in transformers is that transformers are huge and slow. So this is a graph comparing the model size and accuracy. And we see that as we try to increase the accuracy of a model, the model size grows exponentially. And this is, again, for natural language processing, but we can observe an exponential increase of model size every year for large language models. So naturally, there has been a lot of research trying to make efficient transformers, and here is an example of such researches. One professor or CMU faculty working in this domain is Professor Beidi Chen at the ECE Institute, and she is trying to tackle efficiency problems in machine learning from an algorithm modeling or system perspective. One paper from Professor Beidi Chen that caught my attention was Deja Vu. And the key ideas behind Deja Vu is that it's trying to use the fact that attention heads and MLPs in transformers are rather redundant. And so what Deja Vu does is that it uses a separate model to predict which connections in MLPs or which attention heads to use during inference without loss of accuracy. So Deja Vu was an example of trying to optimize transformers, but can we use the fact that we are using transformers for computer vision domain for its optimization? One paper that tackled this problem used the fact that self-attention is costly, but convolutions are not. And convolutions are cheap, but one problem it has is that it lacks global context compared to self-attention. So a natural idea that emerges is from these facts is that can we combine the two ideas? And mobile former does that exactly. And we can see here that mobile former uses a parallel implementation of MobileNet and transformers. And MobileNet is a convolutional neural network designed for mobile applications. So the key idea behind mobile former is that we are trying to use convolutions to extract local features. And using the local features extracted from convolution, we are using self-attention to allow global communication between these local features. Another idea that we can utilize for efficient vision transformers is to optimize tokenization. So what is tokenization? Tokenization is how we transform words to tokens in large language models. And it is essential for both accuracy and efficiency in LLMs. So what about for vision transformers? So we know that the traditional way of tokenization in vision transformers is just using the raw patches of the images. But here in this paper, we use a mixed resolution tokenization. So what we do is that we use low resolution for less important parts of the image. And using low resolution allows less tokens for those areas. resulting in substantially decreased sequence lengths and thus resulting in a much more efficient transformer inference. So some future directions that we can think of from these prior works is first, can we use domain knowledge? Can we use the fact that we are using transformers in computer vision for better sparsity? So for example, we can perhaps expand upon the paper Deja Vu and use some ideas that we know from computer vision to allow better sparsity in MLPs or attention heads. Or can we expand to other domains in image, such as videos or object detection or segmentation? And finally, can we use more sophisticated encode-decode strategies other than low-resolution encoding tailored for image domains? So those were some future directions that I found from prior research, and these are the citations. And thank you for listening to my presentation.